Hello, welcome back to Learn Physics. In today's topic, we are continuing with the revision topics of units and measurement. Okay, before starting, I need a suggestion from you because usually revision topics, the questions I'll be typing at the right side of this screen. But last video I didn't do like that. Why? Because the questions are not so complicated and all. It's easy questions only. So only I was directly reading and doing the numerical here on the board. Okay, so if you feel like it's comfortable, if you are getting it in a typed way on the right side, then my editing work will be more. Then also, if you are comfortable in that way, you please comment it. If the comments are more, say you want, that means I will do. Okay, it's not an issue. Okay, anyway, you should study. Okay, so the next question is, light year is the unit of light year. Light year means it is the unit of length. Okay, so what is the distance which light is traveling in 1 year? That is light year. So seeing the word light, don't think it in another way. It is the unit of length. Light year is the unit of length. Next is kilowatt hour is the unit of. Kilowatt hour is the unit of energy. Kilowatt is the unit of power and kilowatt hour is the unit of energy. Okay. So next question is, all the physical quantities can be expressed in terms of its dimensions. Write a physical quantity of the following dimensions. Say the first dimension is given as mLt to the power minus 1. And second one is mL square t to the power minus 2. Okay, so L t to the power minus 1 means it is velocity. Mass into velocity. What is mass into velocity? Momentum. Okay, L square t to the power minus 2. So what is this? V square. L t to the power minus 1 is velocity. So L square t to the power minus 2 is velocity square into m. mv square, that one equation we don't know, right? But we know the equation half mv square. Okay, what is the unit of this one? That is energy. Energy, it is the unit of energy. Kinetic energy, which I am telling. So in any way, see, if it is potential energy means we know potential energy formula is mgh. Mass into acceleration due to gravity is Lt to the power minus 2 into L. So we will be getting it as mL square t to the power minus 2. In which way you are feeling while seeing the equation, if you can split like in any one of the way, you can easily find out. Okay, so this mL to the power Lt to the power minus 1 is the formula for, or dimensional formula for momentum. Linear momentum. It is the formula for linear momentum, and mL square t to the power minus 2 is the dimensional formula for energy. So next is, which measurement is most precise? Vernier caliper having 5 divisions on sliding scale. Vernier calipers having 10 divisions on sliding scale. Vernier calipers having 20 divisions on sliding scale. If number of divisions are more, resolution will be more. Right? If resolution is more, that will be the more precise value. That means, see, 1.734 and 1.67 or 1.3. Which will be more precise value? See, which is having more resolution, that will be more precise value. Okay, so precision will be increasing if the number of divisions are increasing. Then what about the accuracy? Accuracy will be decreasing when the precision is increasing. Okay, so if I am considering 1.34 and 1.2, 1.3 and 1.3429, like that, which will be more accurate value? This will be the 1.3 will be the more accurate value over here. Okay, so what happens to the accuracy when the least count is decreasing? Okay, the least count decreasing means if the least count is decreasing, that means number of maximum how many divisions we can take. If that divisions are decreasing, according to that accuracy will be increasing. Okay, if least count is decreasing, according to that accuracy will be increasing. Accuracy will be increasing. What is the least count? Least distance that can be measured using an instrument. That is least count. If least count is decreasing, accuracy will be increasing. Okay. So the next question is, see, m equals m0 divided by root of 1 minus v square. Using dimensional method, put the missing c square at the proper place. See, m equals m0 divided by 1 minus v square. Here, in somewhere one place, c square term is missing. So, where it can be, where we will be putting that c square term. So, it's a logic. So, here we can take the dimension. Dimension of m is m will be equal to dimension of m divided by root of 1 minus 1 and all dimension is not there. So, square root of LT to the power minus 1 the whole square. Right. So, we know left hand side and principle of homogeneity. Left hand dimension at the left hand side will be equal to dimension at the right hand side. Okay. So, m should be equal to m. That means v square, the dimension of v square should cancel with the dimension of v square. We know c is the velocity of light. So, if we are dividing that with the velocity of light, LT to the power v square divided by c square while we are considering, dimension of v square will be cancelled with the dimension of c square. So, where we should put m is equal to m0 divided by 1 minus v, root of 1 minus v square by c square. This will be the equation. Okay, clear? So, the next one is, name and state the principle used in in solving the above problem. So, which principle we are using? Principle of homogeneity. Dimensions on the left hand side will be equal to dimension at the right hand side. Okay. So, next question is, a student was asked to write the equation for displacement at any instant in a simple harmonic motion of amplitude A. He wrote the equation as y equals a sine 2 pi nu divided by k into t. Okay, 2 pi into nu divided by k into t, where nu is the velocity at any instant t. For the equation to be dimensionally correct, what should be the value of k? Okay, so for the equation should be dimensionally correct for that, and v, here this one not nu, it is v. V is given as the velocity at any instant t. Okay, how we can find out the dimension of k? So here we need to find out the dimension of k. Okay, dimension of y is its distance, right? Displacement. Dimension of y is L. A is amplitude. Amplitude also dimension will be L. So, we will be getting L equals L. So, multiplied by something else is not required, right? So, what will be the dimension of K? It is sine of angle, right? So, whether the dimension, how it will be 2 pi into nu divided by into T, V divided by K. So, this one should cancel each other. V, what is the dimension? LT to the power minus 1. T, what is the dimension? T. Capital T, right? So, what will be the dimension of K to get it cancelled? All the dimensions, K will be having the dimension of L. If K is having the dimension of L, this equation will be valid. K is equal to L, dimension of L. Okay, this is how you should logically find out what will be the value of k. This is not a simple equation, simple questions only, but read the question thoroughly, understand it and approach the question. Okay, that's all. Next is, what is the area of a square of side 1.4 centimeter in proper significant figures? Side is given as 1.4 centimeter. Then area of a square will be 1.4 into 1.4. So we will be getting it as 196. 1.96 centimeter square. So in proper significant figures, that is important. If we are multiplying two numbers, the result should have the significant figures which is equal to the least number of significant figures in the given multipliers. So in this multiplier, which is both are having same number of significant figures. How many? Two significant figures. So here two significant figures are required. That means 1.9. These two terms only is required. Shall we throw it out this, move away this 6 simply like that? No. So we can do the rounding off. 6 while it is coming, since it is more than 5, we will consider previously, so it will be to the previous number. So it will be 2.0 centimeter square. Okay, this is how we will be finding out the significant figures. How we can correct the take the correct number of significant figures. Okay, clear? So the next question is, a physical quantity having both magnitude and direction as a vector, and if it has only magnitude, it is a vector categories the following physical quantities into scalars and vectors. So here force is a scalar quantity or it is a vector quantity. Force is a vector quantity. Then angular momentum L is equal to R cross P. So that is a vector quantity. Then time we know it is a scalar quantity. And work done is equal to F dot S. Dot product is a scalar quantity. So work done will be a scalar quantity. Okay, clear? So the next one is, which of the following measurement is more accurate? Why? See, which is the 500, the questions are 500.00, next is 0.0005 and next is 6.00 kilogram. Which is more accurate? So here, which is the more accurate value over here, which is having more number of significant figures will be more accurate. Say here, how many number of significant figures are there? 3 plus 2. 5 significant figures are here. Here only 1 significant figures. In last class I told you, before the whole number, if we are considering the preceding numbers, that and all will not be considered as significant. See, after that if zeros are coming, that one we will consider it as significant. Okay, and 6.000. So how many number of significant figures are there? Here 3 significant figures are here. So which is having more number of significant figures? 500.00. So this will be the more accurate value. Okay, so the next one is, mechanical power is represented by P equals FV plus AV cube rho. Okay, F is the force, V is the velocity, A is the area and rho is the density. Dimensional formula for power. How we can find out? See, either you can find out the dimensional formula for this one or dimensional formula for this one. That will be equal to dimension of power. So dimension of power will be equal to dimension of F into V. So what is dimension of F? MLT to the power minus 2 into LT to the power minus 1. So we will be getting it as dimension ML square T to the power minus 3. This is the dimensional formula for power. Okay. Next is, check the dimensional validity of the above equation. So dimensional validity means you should find out the power separately. Power means how we can find out the power? This power of an equation is work done divided by time, rate of work done. Work done, what is the formula? Work done will be equal to energy. Okay, what is the formula for energy? ml square t to the power minus 2 divided by t. So we will be getting it as ml square t to the power minus 3. So next FV already we got it as ml square t to the power minus 3. Right. Now AV cube rho. A as area. Area means L square. V cube means L square t to the power minus 3. Minus L cube t to the power minus 3. Rho means density. Mass by volume. Volume is L cube. So we will cancel these two and we will get it as m L square t to the power minus 3. So in all the terms we should find the dimension and write down. Okay. So clear how we are getting this one? Next is, which of the following equations can't be obtained by the dimensional method? So the equations are given by t equals k into root of 1 by g, E equals k m v square, P equals h rho g, n equals n0 e to the power minus lambda t. So which equation we can't use it for dimension? We can't find out the dimension. Which of the following equations can't be obtained by the dimensional method? See, e to the power. This term we can't find out using dimensional method. And k, if it is a constant, the constant value we can't find out. But we can write it as a constant. Okay. And this equation anyway we can write it as a dimensional equation. So exponents, tan, theta, sine, all the trigonometric equations we can't arrange it as in a dimensional method. Okay, clear? So these are some of the important questions which is given in the units and measurement chapter. Okay, so in next day I will be coming with the some of the questions from the next chapter, that is your kinematics. Okay, so I hope it is clear for you, and if you like the channel, please don't forget to subscribe. Thank you for watching. Bye.